Good morning everyone. Welcome to today's maths class. Today we are going to start a new chapter, that is applications of trigonometry. So by using the applications of trigonometry, we can find the heights and distances of the distant objects without going near to them. Okay. For example, let us say you are standing near a tall building. Okay, and you want to measure its height. Okay, let us say that you are in front of Burj Khalifa. What is Burj Khalifa? It is the tallest building in the world. Where it is located? In Dubai. Okay, if you are in front of the tallest building and if you want to measure its height, how do you measure? Okay, or otherwise any tall building or any tower or a temple tower, something. If you want to measure its height, what is the way you have to find the height of the tower or something? So, to measure the height of a tall building, we have to go to the top of the building and then drop a long rope from the top till the ground. Then you measure the length of the rope. The length of that rope is equal to the height of the building. Okay, is it correct? Of course it is correct, but it's not so convenient, right? Then how to find? Okay, now measuring, not only measuring the height of a tall building or tower or tree, something, measuring the length of a river or measuring the length of a platform, railway platform or a bridge, also very difficult to do by taking a long rope or some tape or something. It is very difficult task. But how to do? How to find the heights of the longer things or temples, towers of temples, heights of buildings or some mountains, monuments. What is the way to find? So now we are going to apply the trigonometry to find such types of measures, the heights of the tallest things or the longest things. We can find easily by using the trigonometry. Let us learn how to use trigonometry to measure the heights and distances of the objects. Okay, but so I am going to make the concept very easy. Okay, now before we look into the applications of trigonometry, let us recall the basic concepts of trigonometry. So we must just recall those points. Why? Because we need to use all those basic concepts in the applications of trigonometry. So already we have learned the different ratios of trigonometry. What are they? So if we have any right angle triangle, okay, and one of the angles is 90 degrees and other two angles are acute, we have taken one of the acute angles as theta, and then the longest side which is opposite to the right angle is called hypotenuse, and the side which is opposite to the angle theta is opposite side. Okay, and the side just adjacent to the given angle theta is called adjacent side. Okay, by using these three sides, we have 6 trigonometric ratios. They are sine, cos, tan, and their reciprocals, cosecant, secant, cot. So sine is equal to, sine theta is equal to opposite side by hypotenuse and cos theta is equal to adjacent side by hypotenuse, tan theta is equal to opposite side by adjacent side. Okay, and cosecant theta is equal to hypotenuse by opposite side. Secant theta is equal to hypotenuse by adjacent side. And cot theta is equal to adjacent side by opposite side. So we discussed all these ratios in the earlier classes. And also we learnt the trigonometric values for specific angles. What are those specific angles? Here theta is an acute angle. It always lies in between 0 and 90 degrees. 0 and 90 degrees. It may be 0 or 90 sometimes. So it is an acute angle. Theta is acute angle. Oh, sorry, it is never be 90 degrees. It is below 90. From 0 to 90. So it is an acute angle. Among those acute angles, we have taken some specific angles 0, 30, 45, 60 and 90. And we have learnt the values of the trigonometric ratios for these specific angles as a table. For example, sin 0, 0, sin 31 by 2, sin 45, 1, sin 60 root 3 by 2, sin 91. In the same way, cos 0, cos 30, cos 45, cos 60, cos 90, like the tan, cosecant, secant, cot. So these also we have to once revise before we get into the chapter applications of trigonometry. So by using those all concepts, we are going to learn how to find the heights and the distances of the distant objects by using trigonometry applications. Okay. Now we are going to find the height of a building. See, let us take the height of this building as h meters. Okay, we don't know this value, we need to find it. Okay, and the point at the top of the building we have taken as A and the bottom we have taken as B. Okay, it is a building, otherwise it is a tower or something. Okay, an object. Okay, now an observer standing and looking at the top of the building from the point O. So O is the position of the observer. From this point he is looking at the top of the building. Now if you join these 2 points, the point of the observer, the position where the observer is standing, and the top of the building, if you join these 2 points with a straight line, okay, we will get a straight line. We call this straight line as, so line of sight. We call it as line of sight. Okay, so this is the line from the position of the observer to the top of the building. And see, OA is the line of sight and AB is the height of the building. So let us take this as a line segment AB. So this is the height of the building, that is an unknown value. And also we need to join the point O, means where the observer standing and looking at the top of the building, observing the top of the building on the ground is called the position of the observer. Okay, that is O. And the bottom of the building is B. Let us join these 2 points also, that is the horizontal line on the ground from the position of the observer to the base of the building. Okay. Now observe this triangle carefully. What is this triangle? OAB. So now can you tell me the angle ABO? What is the angle ABO? Yes, it is 90 degrees. Why? Because a building stands vertically on the ground always. Okay, if it is not vertical, we can't apply the trigonometry applications. So the object which we are going to find the height of an object must be vertical to the ground, means that makes 90 degrees with the ground. So we can take angle ABO is equal to 90 degrees. Okay. And also here the angle made by the line OA with the horizontal line OB is called angle of elevation. Okay. What do we call the angle of elevation? Why? Because to observe the top of the building, here the observer has to look upwards like this. He has to raise his neck. So if he looks normally, he looks straight. Okay, the line of sight will make 0 degrees. And if he wants to look at the top of a building or something, he has to rise and he has to increase the angle upwards like this. Then the angle so formed is called the angle of elevation. At the same time, if the observer has to observe a point which is downwards, if he downs his neck to see something downwards, that is called, so then it is decreased downwards. So if you look straight, it is 0 degrees, and if you look down, the angle is still downwards. Okay, that is called the angle of depression. As the observer is looking at the top of something, top of the building upwards, so it is called the angle of elevation. How do you find this angle? Let us take this angle as theta. Okay, this angle can be measured by some surveying instrument. Okay, that is called inclinometer. By using the instrument inclinometer, we can find the angle made by the line with the horizontal. We can measure, we can find the angle of elevation or depression. Let us take this as 60 degrees. Okay, just we have considered the angle is 60 degrees. Now, so let us measure the distance from the observer to the bottom of the building. Let us take this distance. Let us take this distance is 480 meters. I am taking this as 480 meters. Okay. So now by having these all values, we are going to find the height of the building now. Okay. Now look at this diagram. So the observer is looking at the top of the building, the point A, and the base of the building is B. The horizontal distance is OB. So a triangle OAB is formed. This is a right angle triangle. Why? Because the building stands, here I have written tower. Either it is a tower or building, no problem. Okay, we have taken it as an example to understand. So a building or a tower stands vertically on the ground, so it makes 90 degrees with the ground. So ABO is equal to 90 degrees. And here see, we have considered the angle AOB is equal to 60 degrees. Okay. So, and also we know the value. So if you know the horizontal value from the observer to the bottom base of the building, OB 480 meters. And what is required? We need to find the height of the building. So whenever you solve a problem in the applications of trigonometry, the very important thing is we need to draw a nice picture for the given question. That is very important. Once if you get the picture for the problem, given problem, a geometric picture, the problem will be very easy for you. So let us draw a geometrical picture for this data. Okay. Now we have a building or a tower A, B. A is the top of the building and B is the bottom of the, means the point on the ground where the building stands on the ground. And there is an observer observing from a point on the ground. So this is O. O is the point where the observer is standing and observing the top of the building. And see, this angle is 90 degrees. As I told you, a tower or a building stands vertically on the ground. And we need to join the point, the position of the observer and the top of the building or tower. Okay, this is called the line of sight. Now, this angle we have taken as 60 degrees, theta is 60 degrees, and the horizontal distance is given 480 meters. Now we need to find the height of the building, means that is h, that is unknown value. So now how to find the height of the building by the trigonometry, by using the applications of trigonometry from this data. Now observe here carefully, what is the unknown value and the known value. Here we have three sides. What are those three sides? OA, OB and AB. What is the known value and unknown value? Unknown value is h, the height of the building, which we have to find, the question mark. And here the known value is the distance from the observer to the building has been given as 480 meters. This is the known value and this is the unknown value. Now we are going to do the problem, start the problem. So this is the information from the data. Now we are doing the problem. See, in triangle OAB, angle OBA or ABO can write 90 degrees, and angle AOB is equal to 60 degrees. Now the ratio between the sides, so we have to take the ratio between the sides of unknown and known, known side and unknown side. Unknown side, first you have to take the unknown side, AB by OB. We don't know the value of AB, but we have the value of OB. We have taken this. So what is AB? Is H. And what is OB? That is 480 meters. Okay, and one more question. What is the position of this side AB with respect to the angle 60? Okay, we have learnt in a right angle triangle there are three sides, opposite side, adjacent side and hypotenuse. Which side it is H? This is the opposite side of the theta, and this one OB is the adjacent side. Now recall the ratios of trigonometry, opposite side by adjacent side. Yes, it is tan. So AB by OB is tan theta, that is equal to H by 480. Okay, now this implies tan theta. What is the theta value given in the problem? 60 degrees is equal to H by 480. So did you remember what is the value of tan 60? Root 3. Root 3 is equal to H by 480. Then H is equal to 480 into root 3. Do you know the approximate value of root 3? So it is an irrational number, we can't tell the exact value. 1.732, which is equal to, let us multiply this, 480 into 1.732. So let us do once again. $480 we get 831360. If there is point, we get 83 point. So h is equal to approximately we can take 83.14 meters. So this is the height of the building. So like this we can find the height of an object which is very farther from you without going near to it by using applications of trigonometry. Okay, so not only the heights, we can find the distances also. So like that we can apply the trigonometric applications to do it. By this knowledge, let us go with the problems from the exercise 9.1 in the next class. Okay, thank you. Have a nice day.